So on the test, the whole thing.
We balls.
Okay, put your iPads away. Okay, we've got perpendicular bisectors, angle bisectors, medians, and altitudes.
Yep.
So that's the main part of it. Perpendicular bisectors meet at a point called the circumcenter. And the circumcenter is equidistant from all three vertices, all three corners. So this is different depending on the type of triangle that you have. If it's an acute, a right, or an obtuse. Now, on the test, you are going to have to sketch some of these.
Oh.
Okay, so it'll tell you what kind of triangle to draw, like an acute or a right and obtuse. And it'll tell you to either draw on the perpendicular bisectors, the angle bisectors, or the medians or altitudes. Okay, but there's only two of them out of those possibilities. So the perpendicular bisectors, when you draw that, you got to bisect the side, so just figure out where the middle is, and then you just draw a 90 through it. You got to put that it's 90. If you forget to do that, that's a half point off. And then you got to show that it's bisected. If you forget to do that, that's a half point off. And then this side, show that it's 90, show that it's bisected, and remember they will intersect at the same point. That one got off a little bit, but okay. So that's how you would sketch it. On a right triangle, it would look like this. That's supposed to be right there on it. So on an acute, they intersect inside. On a right, it's on it. On an obtuse, it's outside. There are some questions about where they intersect, the sometimes, always, never questions. So on this one, it'd be there. They'd intersect outside. So, if they asked you, do the perpendicular bisector sometimes, always, never intersect on a triangle? You'd say sometimes. Okay? Do they intersect in a triangle? You'd say sometimes. Okay, so what this tells us then is the distance from here to here, here to here, and here to here are all the same. From there to there, there to there, and there to there. This one, and this one are all the same. Okay? Then on the angle bisectors, they intersect at a point called the incenter, which is equidistant from all three sides. Now, if it's an acute, right, or obtuse, these will always intersect inside. And again, if you're not sure what it is when you're doing these, just sketch it out quick and see where they intersect. So to show an angle bisector, you gotta, cut it in half as well as you can, and then show that that equals that. Put those marks there. Again, if you forget the marks, it's a half point off. Show that one. Put 2 marks there and 2 there, and then this one. So then you'd put 3 marks and 3 marks. Okay? So there's the incenter. So this one would be like there, there, and there. And this one would be here, here, and there. So, this tells us the distance from the in-center to each side, that distance, and that distance are all the same. So there are some problems in here on the test where they'll give you this distance and they're wondering what's that. You just got to realize that they're the same. Now, the thing you need to know about these two, and I'll show you some examples when we do them, that'll be on the test, is anytime you have a perpendicular bisector, any point on this line is equidistant from the two endpoints. Remember, but well, that's the very first thing we learned. So no matter what point you pick, they're going to be equidistant. Okay, everyone put their stuff away now. So if I pick a point up here, it's going to be equidistant from each point. On the angle bisectors, anything on this line, no matter where you pick, is the same distance from each side. Okay? Then the medians they intersect at a point called the centroid. So it doesn't matter, this is similar to the angle bisector, whether it's acute, right, or obtuse. They're always going to intersect inside because it's the balancing point. A median just goes from the center, so show that it's the center, to the opposite vertex. Sometimes it could be perpendicular. So then here is about the middle, so it'd go like that, and you'd show that this equals that, and then there. So there's the centroid. So the median here would go from there to there, here to there, oops, and there to there. And here, there's the middle, so it'd go like that, and like that. So, the only thing you need to know about that is these lengths. So like if this is 10 right there, everyone remember what? It's half. That's 5. Okay? If this was 6, this would be 12. The shorter one is always half of the bigger one. Now if they did give you the whole length, say that AB was 15. Yes. What you do to figure it out is divide that by 3 and you get 5, which means the shortest one is 5 and this one is 2 5s, which is 10. Okay? But I don't think they have any like that. I think they're all like that. And then the last one is the most useless one, the altitudes. And again, the sometimes, always, never questions. They would say is the centroid sometimes, always, never. It's always inside no matter the triangle. The altitudes are similar to the perpendicular bisectors. They meet at a point called the orthocenter. And this is on the test. There is a question about the orthocenter on the test. So you need to know if they talk about an orthocenter, then it means it's an altitude. So, altitude just measures from one vertex straight to another side. It just tells you how tall it is. So this one would measure from there to there, and this, they all meet at a point like that. So it's like if you had it on the bottom, you'd go straight up. If you tipped it on its side, from here to here is the height. This would be from there to there. On a right triangle, the actual side is an altitude, because that's how tall it is. This side is an altitude, and this side is an altitude. So there they meet right on the corner. This is the trickiest one. Here there's one altitude. To get from here to here, do you remember what you gotta do?
Gotta go on the outside.
You gotta extend it out, yep. So there would be an altitude. Extend this out, there would be an altitude. So if you continued them down, they would intersect down here. So again, the ortho center sometimes is inside, sometimes it's on, sometimes it's outside. Okay? And this doesn't have anything, we don't have to figure out any numbers or lengths using the altitudes. So, I'm going to show you a couple problems then. But again, on those, you need to know those properties, and you need to know how to sketch. There's just two of them you got to sketch. So, we had a problem just like this in the book. They say that if SQ is the perpendicular bisector, what do you know about RQ and QT? They're congruent. So if they had it like this, if this is 4 and they ask for QT, that's just 4. Then if they told you, this was the same exact question that was in the assignment if you remember, if they tell you that RU is congruent to UT, what do you know about U?
It's on the line.
Right, that's it. It's so easy, it's hard. Since U is the same distance from R and T, you would say it's
On the bisector.
on the, make sure you put perpendicular bisector. Okay, you can't just put bisector because there could be there could be an angle bisector. If a point is equidistant from each side, it's on the perpendicular bisector. Okay? So here are some examples. These are perpendicular bisectors. They want us to find KR right there. So they tell us we know that this equals that, right? Well, what we have here is this is 12 and this would be 16, right? On this piece, because it's 32 all the way across. So you got to find that. So you use the leg squared plus the leg squared equals the hypotenuse squared. I just want to check to make sure we even have to do that. Now, there won't be any with the Pythagorean theorem on there because we really haven't gone over that. Okay? So the types that we'll have will be this simple. They'll tell us like this is 20, and then they'll ask what's KR? 20. Because these are the same if it's perpendicular bisector. Same thing on the angle bisectors. They want us to find WB. They'll say like that's 4. So WB is the same, that's 4. Because angle bisectors are the same distance away. Okay? Yep. So those are that easy. Here we got the medians. They don't have an example of it, but it's like I showed you. If this is 12 and they ask for PE, it's 6. Now make sure, sometimes they show it like that and they ask for BE. So there you got to realize that that's 6, so BE is the whole length, so that'd be 18. We already went through the point of concurrencies. If they're angle bisectors, it's an in-center. Perpendicular bisectors is a circumcenter. Medians is the centroid. Altitudes is the orthocenter. Okay, mid-segment. If you connect the midpoint of each side, it makes lines parallel, and it's just half as long as that side. So, in this picture, if this is 12, this side is
24.
24. If this is 9, which means this is 9, so this side would be 9, because the whole thing's 18.
Yeah.
And then, if this is 22, this is 11. Okay? And then remember, the perimeters are half as much, which you can figure out the long way, but if you know one of them, the perimeter of the little one's just going to be half of the big one. The perimeter of the big one is double that one. Now, there are a couple like this. Okay? And you got to figure out what X is. Now, right. These are not equal right now. X plus 2 does not equal 6x plus 10. So I can't write that equation, but what I could do is I could double this or half this, and then they'd be equal. Because 2 of these is the same as one of those, or one of these is the same as, or half of that's the same as that. So I could double this and write 2x plus 4 equals 6x plus 10, and then I could solve it. Everyone understand that? So I would just get the 2x over here. I set it up wrong, so I'll get a negative, but that's all right. Move the plus 10 over, so I'd minus 10. Divide by 4, and I'd get negative 1.5. Okay, there's a couple like that. These inequalities, write the angles from least to greatest. So the smallest side is 8, so the smallest angle is C. So make sure now you write it, angle C. Put the angle symbol in front of it. And then 9 would be for A, angle A, and then the biggest would be B. If they give us the angles, then you do the sides. Here we got to figure out what it is. That's 70 and 50 is 120, which means that's 60 because they got to add up to 180. So the least or smallest side would be opposite 50, GJ. So when you do a side, all you need is the 2 letters. Don't put an angle symbol in front. And then 60 would be HG, and then 70 would be JH. And then there's a whole page of like the one we just corrected, so that should be pretty easy where it's greater than or less than or equal. How does AB compare to CB? 88 is less than 92, so AB is less than CB. Ever remember that? Here, angle 1 is opposite of 15, 2 is opposite of 16. So 1 is less than 2 because 15 is less than 16. Here, TU is opposite 126 and so is SV. So they're equal. So I believe that is everything. Oh, no, one other thing. Just find a blank space here. If you've got 3 sides, can the three sides form a triangle? It's just a yes or no. 1, 2, and 5.
No.
No. Everyone remember how to tell?
1 plus 2 equals 3 plus 5.
Yep. Any two sides gotta add up to more than the third.
Yeah.
6, 7, and 8?
Yeah.
Yes. These two are more than that, these two are more than that, these two are more than that. Make sure you don't get one that's equal, like 4, 4, and 8. No, because 4 plus 4 is exactly 8. It wouldn't form a triangle. It's got to be greater than. So these are just yes or no. That's everything.